Hi student, our study today about parabola. Parabola is the last part of the conics. Since we took before circle, then ellipse, then hyperbola. A parabola, if this is the general form of the equation of a conic, if A is 0 or B is 0, we have a parabola. It means either x square is missing or y square is missing. In ellipse, we said, or first of all, in circle, we said if coefficient of x square and y square are equal, we have a circle. If a and b coefficient of x square and y square, same sign but not equal, ellipse. If a and b opposite sign, we have a hyperbola. If x square is missing or y square is missing, we have a parabola. What is a parabola? A parabola is the set of all points equidistant from a fixed point called focus and from a line, it can be vertical or horizontal, such that any point on the periphery, if you calculate the distance from the point to this line, it can be, as I said, vertical or horizontal, and the distance from the point to the fixed point focus, they are equal. In that case, we say that the eccentricity is C over A. Let us take the GeoGebra to understand, let us say take some graph and we can figure out by using GeoGebra of a parabola, definition of a parabola. Suppose I want y square equal 8x, for example. Y squared here equal 8x. So here if I put focus, I have focus of conic C. Let me rename to be C. So if I put focus here, conic C, and if I put directrix, this directrix, the line vertical or horizontal, is called the directrix. Okay, let me put the directrix as dot points. To differentiate it from the x and y axis. Okay, now if I pick any point on the parabola and I do the distance from the parabola to the fixed point, and I do the perpendicular from this point to the directrix, and I take the point of intersection, then I measure the distance from B to this point. Okay, so as you can see, it's 4.7, 4.7. If I do animation, as you can see, you can look at it. They are changing, but they are always equal. Okay, and if you want to be more accurate, let me put, for example, m, which is g over I, always must be equal to 1. As you can see now, when I made g over I, because they are equal, it's not changing, it's equal to 1. So the parabola is the set of all points equidistant from a fixed point called the focus, and a line, it can be vertical or it can be horizontal. Horizontal, let us take an example of a horizontal. Instead of writing y squared, I can take x squared equal, for example, 12y. In that case, as you can see, now you have the same thing here. Equidistant, and the ratio is 1. Distance from this point to the directrix over focus, it is 1. Okay, so let us take all possible form of a parabola. The parabola, you took it in grade 10. I'm going to start by the vertical. You know, in grade 10, if y equal ax squared plus bx plus c, which was a equation of second degree, graphically it was a parabola. So if you have x squared, this is called a vertical. If the coefficient of y here, which is p, is positive, it concave up. If p was negative, it concave down. And always the coefficient of y, when you write it as x equal 4py, this p is the distance from the vertex of the parabola. Here the vertex is 0 0, because like we did in circle, x minus 0 all square equal 4p, for example. P we can y we can write it as y minus 4p into y minus 0. So here the vertex is 0 0, and this p is the distance from the focus to the directrix. Okay, if p was positive, it will concave upward. If you have x squared, because you have x squared, it is vertical. If p is negative, it concave downward, and the distance from the vertex to the directrix, or the vertex to the focus, it's also equal to p. If you have now y square equal y square, it is horizontal. If p is positive, it concave toward x positive. If p is negative, it concave towards y negative. Here the vertex is 0 0, and p, as we said, is the distance from the directrix to the vertex, and directrix and the vertex to the focus. Let us take example to understand it better. Suppose I want to graph y square equal 8x. This is a parabola because x square is missing. Only I have y square, and it is written in standard form. Y square equal 8x. First of all, because y square it's horizontal, because here 8 is positive, so it concave towards towards x positive. Now the vertex is 0 0. My aim is to find p. As we said in the beginning, y square equal 4px. So 4p is 8. So this is 4p. Always this is called 4p. So p is 2. So we take from the vertex 2 from that side and 2 from the other side. So the focus is inside the concavity of the curve. So here, since it is horizontal, so f will be the focus to 0, and because this line is vertical, it will be x equal minus 2, and always eccentricity is 1. Now I want to graph the parabola. To graph the parabola, I have y square here, always must be positive. Let me take a number for x where y square is a perfect square. You can take 2. So y square equals 16. If you remove the square, y square equals 16. You have y is a plus or minus 4. So if x is 2, you have y equal plus or minus 4. Okay, so you can locate these 2 points. X is 2, y is 4. X is 2, y is minus 4. You have the vertex here, which is I. You can graph it. You can take more particle point as long as you want. Another example, also I have y square. Since I have y square, it's horizontal. Since coefficient of x is negative, it concave towards y negative on this side, y negative. Now, center is 0 0. 4p is minus 2. So P is minus half. So minus half is distance from the focus to I, and from the I to the directrix. Always the focus is inside. So the components of the focus, because horizontal, minus half 0, and the directrix will be on the other side, it will be half. Eccentricity is 1. And if you want to take particular points, let me take here y squared. So x must be negative to be accepted. Minus times minus is a plus. A perfect square number, you can take x to be minus 2. So if x is minus 2, y squared is 4. In that case, x will be minus 2 and 2. Another example. Here I have type of vertical. I have x squared. X squared vertical. P is positive. It concave upward towards y positive. This is y positive. So 4p is a 12. So p is a 3. So I take a 3 from that side, from the vertex, which is 0 0, and 3 downward. Focus is always inside, so it will be 0 3, and directrix will be horizontal line y equal minus 3. For particular point, you can pick y to be 3 to be perfect square, 36. So in that case, if y is a 3, x squared is 36, and in that case y will be minus 6 and 6. This is the first point here, and the other point here. More example, x square also it is a vertical. Since here it's negative, it concave towards down. Certainly here the center is 0, 0. 4p is minus 8p is minus 2. So I take for focus inside minus 2 and here 2. Okay, so the focus will be 0. In that case here the focus 0 minus 2 and the directrix y equal to eccentricity is 1 because the x square I must take y to be negative. I can take it as minus 2. So x square equal to 16, x equal plus or minus 4. You have this point and this point. Don't forget, because p here is negative and the parabola is vertical, it concave towards vertical towards y negative. More example. Now I'm going to take example where the center is not the origin, like we did in ellipse and in hyperbola. So first of all, I have y square equal, this is positive. Y square, it's vertical, it's horizontal. Since p is positive, so it will concave towards y, x positive. This is x positive. Now, first of all, I find p. For p is a 12, so p is a 3. Vertex here is minus 1, 2. Here, minus 1, 2. So I do it as with respect to x, I, y. Suppose this is the x, then I transform it to x or y, like we did before. So since p here is a 3 and it concave towards y positive, so here will be the directrix, here will be what? The focus. So the focus, since p is a 3, I go 3 units behind. So it will be towards x is positive, so 3, 0, and directrix will be, as we did up, x minus 3. Now, because I want it with respect to x or y, I add for every x minus 1, and for every y 2. So you're going to get 2, and 2 plus 0, 2, and for x here, you add only x is minus 1, since I don't have y. So it will be x equal minus 4. This is with respect to x or y, and you can take particular point, you can replace. Most important here to get a positive, and I took 2 for x. 2 plus 1 3, 36 square plus or minus 6, so it will be 6 plus 2 and minus 6 plus 2. You have the particular points. More examples, irreduced form. So here this is, sorry, the center is not the origin, it's in reduced form also. X squared, so it's vertical because x squared. Since p is negative, so it concave towards down, so it had that shape. 4p is minus 12, p is minus 3. So here the center minus 2, and here I don't have a parenthesis for y, so 0. So I want to take that this I as the new origin. Since it's vertical and the shape is here, the focus must be from inside. So it will be 0 minus p. 0 minus 0 and p, sorry, 0 here because it had that shape. The focus must be here, as you all know. So 0 minus 3, and the directrix from up, so it must be, this is the new axis I'm talking about. Forget the old one for a while. It will be y equal to 3. Since I wanted with respect to x or y, I add for every x minus 2, and for every y 0, you get these. Eccentricity is 1, and you can take particular point. Here I took y to be negative because square cannot be negative, so I must take y to be negative, minus times minus to be positive. The last example, suppose it's in a reduced form. Because I have x square, I don't have y square, so this is a parabola which is vertical. So I take the x's together and everything without x to the other side. I do canonical here as we used to do. 4, I divide here by 4, you're going to get 4x squared divided by 4x squared, 12 divided by 4, 3. I put big parentheses, x plus, I divide coefficient of x by 2, then I square it minus this number here square. Then I distributive, I multiply this by this parenthesis, 4 times minus 9 over 4 minus 9. Then I take the minus 9 to the other side, it will be 20y plus 4. So I put here now coefficient of y in factor 20 into, I divide here by 20, here by 21 over 5. Then this number here I must take it to the other side. So I divide by 4, I have the reduced form. So now I'm in standard form. In standard form, as we said, it's a vertical. P is positive, it concurves towards up. The center is -3/2 -1/5. So if you take this is the new axis with respect to I, so the focus will be from up. So 0 and P, which is 5/4, and directrix horizontal Y equal -5/4. I add for every X -3/2, for every Y -1/5 here. You're going to get these points, eccentricity and is 1, and you can use your calculator to get any particular point. Thank you for listening and see you in class.